Hello, unmute yourself.
Sir, LOM used
Long
deposition.
abbreviation with abbreviation, pronouns with abbreviation.
Sir, laminated
Laminated.
object
Uh,
manufacturing. Sir,
okay, second one.
fuse
Second one,
deposition modeling. Sir,
fused deposition modeling. So through extrusion phenomena, the technique was developed. Fused deposition modeling. And what are the third powder-based rapid prototyping techniques? What are the two powder-based rapid prototyping techniques? Just recall yourself. Just powder-based rapid prototyping techniques. Just from few classes we
SLS.
are
Sir, SLS.
SLS, selective laser sintering. Selective laser
Lab
sintering. What is the
3D
different?
printing. Sir.
What is the main flexibility we have with SLS when compared with SLA? When compared with SLA, what are the main benefit or advantage we are having for SLS? We can recollect. So supports are not required. The the product development time will be reduced because of absence of supports. Whereas SLA technique, we are having supports, requirement of supports. And we have given in the yesterday's class, we have given comparison between different RP techniques also. What are the advantages? What are the materials used for different rapid prototyping techniques? So 3D printing also, what are the applications for 3D printing? So almost all techniques nowadays they are calling as 3D print, and the other name for additive manufacturing is also nowadays many people has named it as 3D printing. That is same phenomena, development of 3D model. That your knowledge is required to develop the CAD model from different inputs. From different inputs, your knowledge, I mean, whatever may be the complex designs, customized designs, some customized designs. So let me, we are having, are you, are you able to see screen? 3D printing a space vehicle. Hello?
Yes,
Yes,
sir.
sir. Interesting, sir.
Visible.
Okay. So here NASA, what is the abbreviation for NASA? Any one of you? NASA. You, many times you have heard that word, NASA. National Aeronautical and Space Administration. National Aeronautical and Space Administration. So they have developed a parts for the human supporting rover. So the mission is human supporting rover from FDM technique, fused deposition modeling. So this is the component they have developed. This is the mission. Some of the parts have been developed by this particular FDM technique, fused deposition modeling. So every time we are going for each and every technique, we are discussing the case studies. This is the one of the case study. Uh, so the agile white vehicle roams at a desert and maneuvering the, the unforgiving terrain as wind and sun beat down. Some temperatures swing from one extreme to another. So here the different effects these particular vehicles have to uh, bear different temperatures, resist different temperatures. and also wind force. So all this taking into the all these aspects into the consideration, they have designed the parts. So about the size of the humor and boasting pressurized cabin to support the human in space. So when human are traveling in the space, or the cabin, the design of pressurized cabin. So it was developed by Stratasys. Stratasys, the company, 3D printing solutions company. See, here they have given the detailed information about these particular components. The rover is an integral part to the NASA mission to extend the human reach further to space. So what I have said is that so for a to reach the human to the space, vehicles are needed. So this is the rover is the integral part for this operation. I mean for this work. So 3D printed rover parts to design a tenacious and specialized vehicle. NASA engineers draw an integrity and advanced technology. For example, 70 of the parts which is makeup of rover was built digitally. So here they need customized components or parts. So they have gone through the 70 parts for producing 70 components, 70 different components. They have used this 3D printing technologies. I mean, they are calling it as built digitally. Built digitally means here they have used this 3D printing technology. So directly from the computer designs in the heated chamber of a production grade Stratasys 3D printer. So the name of the printer and also the heating chamber of a production grade. So this particular mission, I mean, they have given just introduction about the FDM mission. So this mission is termed it as FDM mission. So when you are building a handful of highly customized vehicles and subtracting them, otherworldly punishment, stock parts and traditional manufacturing methods are not enough. So here you can observe here a person is modeling some of the wheels required for that vehicle rover. So customized wheels are required for that atmosphere, for that conditions, for that environment, whatever maybe they are facing. So there they have implemented these particular technologies and highly customized vehicles. So when they previously also they have launched many vehicles. We have Vikram Sarabhai. We are having launching with different vehicles. SAR, and we are having in at Nellore we are having at launching vehicle stations. See, 3D printed parts. So when they followed the traditional manufacturing methods, previously this technology was not. I mean, in 80s itself it was developed, but it was came into existence in real-time applications in 2000s only. Actually, in 80s it was developed, but in industrially or uh, companies they have implemented these techniques in their manufacturing area starting from 2000s only. So they have implemented this, and for example, one ear shaped exterior housing is deep and contoured and would be impossible is positively extensible to mission. So this is the one of the part, ear shaped exterior housing. This is the name of the part. So this part when they fall, I mean having the deep groove and contour. Contour means a special shape in the component. So when they thought that it was impossible, almost it was impossible means they may not get exact results. I mean, in the aspects of surface finish, or in the aspects of tolerances, in the aspects of accuracy levels. So, and also when even though it is possible, even though with high difficulty if they produce that components or that particular machinery equipment, so it was very expensive, very expensive. They need high skilled professionals for the both designing I mean, for the development of concept. It is we are facing here also, but manufacturing high skilled operators are required. Even CNC machines they are going to develop with the help of CNC machines. So special contours will not be developed all time, and it is again the CNC machine, it requires the CNC machines, it requires again tool design also. So the tools which are going to be prepare these particular shapes, special shapes, some SPMs are there, special purpose machines. So those are also required, previously used, but nowadays all separate manufacturing are replace. I mean, most of the separate manufacturing methods are replacing with the additive manufacturing, that is depositing of materials. So by this technique, very less, I mean, wastage of material is very minimum, or it will be completely vanished in some RP tech, I mean, additive manufacturing techniques. Why? Because it can be recycled and reusable. And using here, the issue is the we are going to provide some laser or UV lighting, I mean UV system and photopolymers, somewhat, I mean, for metal and composite products. Still they are following traditional methods. So they are developing day to day these particular 3D missions to produce the components. Metal components, it takes, what is the major drawback of this 3D printing is it takes much time. Even though component is small, it has to, whereas subtractive manufacturing, if you want to drill a hole, what we are going to do is just creating the hole, and I mean, we are going to program in CNC machine, just it is going to be drill or groove into the object. So it takes very less time. When coming to additive manufacturing or 3D printing, here the same grooves or same holes if you want to drill or provide, so there we have to develop outer surfaces. That means other than the hole, we need to develop other area of the component. So there layer by layer it takes much time. So preferably for that application, they will go for CNC machines. Okay. So always additive manufacturing is not suitable. Always traditional manufacturing is not good. I mean, now, so they are developing, still they are developing to accommodate all the features in the machines. Capacity, I mean, they are going to improve the capacity of the machines day by day. So they have given a failure is not an option. So here they have given some their case study. It is a case study. You always want to be a light as possible, but you also want to be strong enough that you got your safety factors. So they have given generalized statement. So this is the one of the case study. NASA engineers also 3D print prototypes to test form, fit, and function. This is a triple F: form, fit, function of parts they are eventually built in other materials. This ensures the machined parts are based on the best possible design by solving the challenges. So whatever may be the challenges they are facing in traditional manufacturing, that will be replaced, or that will be accomplished with the 3D printing. So this is one of the case study, and let me share. So General Motors, one of the company you have heard, I think so, General Motors. So let me share that.
Every vehicle platform is touched in some way, shape, or form here in the Rapid Prototyping Lab, whether it's a car or truck, overseas, or here for General Motors, is touched by this department. We have supported the product development and helped reduce the lead time to the customer and to market through the Rapid Prototyping Lab. RP technology has been a great help to eliminating the carbon footprint or minimizing that carbon footprint. Anything with weight that you can start to reduce utilizing alternative materials helps to that end goal of eliminating weight, saving gas. Our customer base is quite broad because they know that they can get it from us, get it quick, and get it right. And there's virtually little to no cost.
Rapid prototyping allows us to understand our designs, not only as far as a technical aspect, but from a very functional, very touch and feel aspect. Once we actually finish or establish a design direction, we use rapid prototyping to quickly understand what it is about the design that would enable or enhance ergonomics and functionality of every single part. At a studio level, it gives us a sense of the final design because of its speed, its accuracy. Some of the benefits above that is being able to fit various components together and understand part-to-part interfaces. Rapid prototyping has enabled us to elevate the quality and craftsmanship of our components, and that is ultimately the goal in designing world-class interiors.
Rapid prototyping is very important in aerodynamics. Every model we have has some sort of rapid prototype part in it. The reduced scale models, the full-size models, even when we get into integration vehicles or production, we still use rapid prototype parts on those vehicles. They're important to us because we can get actual surface from designers with perfect contour that fit on our model in a very short amount of time. In the past, we would have to wait until we had the production tooled parts in order to get a drag number off of it. Now we don't have to do that thanks to rapid prototyping because we can have the actual part made in the RP lab. Even though the production tool's not ready, we have the data. So we can make it out of the RP lab, put it on the car, and get the actual drag data off of it. If we have the right parts at the right time, and we can get the data upstream enough, then we can get more drag reduction into the vehicle, ultimately resulting in better fuel economy for the customer.
This process has proven out to eliminate a lot of early stages of tooling for engineering, for manufacturing, and it is just a fantastic medium to have. As a matter of fact, right now we have a resin that has a clear resolution to it and has just a slight blue pigment. Can actually be used for actual lenses that go into our clay type properties and some of our foam model properties, where we wouldn't have to go ahead and duplicate or replicate that part in a casting procedure. DSLS, again, that stands for selective laser sintering, and that being a powder form, and in the engineering world, that is a big medium that is used in a lot of the plastics that they use in an IP or in some of the parts within a seat structure, seat surround, etc. Virtually unbreakable type material, and it comes right out of the machine, go right over to the...
Here they are going to remove the excess material, and this powder-based SLS technique they have used for development of these customized parts, and this powder can be reusable. This is metal powder.
Technician or the engineer and go out for validation. It's a fabulous material. We are actually a beta site testing facility for 3D, whereas they go ahead and they find different machine changes that they may want to incorporate that they think can continue to increase the quality, reduce the lead time, build it faster, quicker, better. We are the first ones that they come to say, hey, what
Discussing about the lead time, every time the manufacturing technique is related with the lead time. That is, we need to minimize the machining time.
you think about trying this out? By being a beta tester with that, that gives us a leading edge over our competition, if you will, and we have done real well with it. Yeah, just returning from the World Conference in Belgium, I walked away feeling extremely pleased that where our foothold is in this technology, General Motors is on the leading edge, and it is just a fantastic medium to have to our arsenal of tools here in a pre-production environment.
So this is about the automobile sector implementing 3D printing technologies. So we are having agricultural, it is new to us, but even in agricultural sector, also agricultural machinery, they are going to use this particular 3D printing technology. Let us see that application, and someone awarded for the 3D printing also.
Toy Tractor Times is at the.
Are you able to see screen? Hello? Please
No, sir.
respond. Now, is it visible?
Sir.
Times is at the 2017 National Farm Toy Show. We're here with Adam Frericks. Congratulations on taking a gold trophy, second place in a very competitive small scale division. Great job, Adam, and looking forward to learning more about your farm.
Thanks, Jason.
So, Adam, what did you bring out to the show this year?
So this year for the farm display, we tried to go with just a small farmyard, just kind of a lot of moving pieces on it, kind of a lot of different area here. Kind of shows the growth of the farm, I guess, starting with the two guys.
These are the prototypes before the agricultural machinery have been developed. So they have tested as with the prototypes.
Nice buildings, lots sit in the shop there in the middle. And the farm would have added on the machine shed here in front by the road, and also the bins over there on the far side of the display.
Well, let's start in here in the modern building, because there's a lot of nice equipment here.
Right, so here in the newer machine shed, we got a lot of 3D printed stuff that I designed, or had designed and then finished out myself. We got a R4038 sprayer, the dry fertilizer box on the back there. The Susi tracks on it are printed, as well as the tarp kit for that.
That's really neat. I know you shared that on a Toy Tractor Times Workbench Wednesday. And
Yep.
It's a cool machine.
Yep, sure did. It's got my handrail kit on it. Kind of did a repaint on some of the plastic parts and everything, as well as the spreader box on the back end of the spreader there. It's got the product from Circle C that he uses on his DN345. So that's kind of a common thing across the new leader brand, to be able to spread that. Just a few small things to spruce that up and get a good dry spreader.
You got some big J&M carts?
Yep, so we got a couple 1326 J&M grain carts. These are models that I designed and 3D printed myself, so they're 100% 3D. On the first one with the tracks, the one in the back with the tires, those are off the brand Unverfirth, whatever brand grain carts you want to call those ones, Kilbros. The augers and everything function on them. I can show that they fold out, and just
Nice
like the
corner
real
auger.
board. You bet.
It looks like we've got a fast applicator here.
Right, so that's a fast side dress applicator. That's the 8200 model. So that's going to be like a 23 row. Folds back on the sides. Duals, 2400 gallon tank. That's 100% 3D printed. That's kind of one of the great things about 3D printing.
Really functional, but they have created all conveyor system. Here it is that is load management, load carrying equipments. So here is some sensor. So why ask your friends to not to send a request in the meanwhile of class.
You get those odd-shaped tanks and kind of really opens
It's just
up
amazing.
Options.
It gives so many new options for displays.
Right.
So the next item up.
Post